To go along with the introductory solar system lecture, you'll have two activities that try to illustrate the scale of the solar system. In this first activity, we're going to look at distance scale, or basically how the planets are spaced out. In a lot of illustrations in books, it looks like they're all relatively evenly spaced throughout the solar system. But that isn't true at all. For this activity, you'll just need some receipt paper, about a meter or a yard long. It doesn't have to be exact. Here you can see two receipts I found in my recycle box. I'm going to use the blank backsides of these. If you don't have any receipts, you can use a regular sheet of computer paper. You'll just need to cut it into several strips and then tape the strips end to end. In this image, you can see that I just taped my two receipts together end to end to make one long strip of paper. You could even use a strip of 10 squares of toilet paper, but that's more difficult to write on without tearing. Start on one end. Label it Sun and with the number 0. Here, the 0 is standing for the center of our solar system. On the other end of the strip of paper, label it Pluto/KBO. Recall from the introductory lecture for this unit that Pluto is a member of a large group of objects called the Kuiper Belt. And anytime you see the abbreviation KBO, it just stands for Kuiper Belt objects. Kuiper is always capitalized because it's a guy's last name. To go with this label, also mark it as 40 AUs, as Pluto is on average 40 astronomical units away from the Sun. Now take your strip of paper and fold it in half and then in half again. Make the creases heavy so you can see them easily when you open it back up. Once you open it up, you should be able to see your fold marks. Mine are a little difficult to see because my receipts were pretty wrinkly, but they are here, here, and here. Label the first one closest to the Sun, Saturn, and 10 AUs, the center one, Uranus, and 20 AUs, and the one closest to Pluto should be labeled Neptune, and 30 AUs. Your product so far should look something like this. Each of those 5 labels evenly spaced from end to end. At this point, it's important to recall the order of the planets. Remember the dorky phrase, "My very educated mother just served us nachos," to remember the order of the planets. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Those of you as old as me probably learned the end as 9 pizzas for Neptune and Pluto. Either way, notice that we've labeled the full length of our strip of paper, but we've only done the last 3 planets plus Pluto. Also notice that the center of your strip of paper is Uranus. And even though it's the 7th planet out of 8, it's only halfway out to the Kuiper Belt. And my terrible joke that I love so much, if the solar system were the size of a person, Uranus is right where you'd think it would be. So the question remains, where is everything else? To get the ones farther than Saturn, they will all have to be smashed in between the Sun and Saturn, as they are all less than 10 AUs from the Sun. Make another fold, this time folding the edge of your paper labeled as the Sun to where Saturn lies, so that you get a crease mark that is at the halfway point. This is where Jupiter lives, at 5 AUs from the Sun. Sorry for the part that I'm covering here. I had already worked ahead a couple of more items before I realized my photos came out blurry. You'll see this part momentarily. Now we have all 4 of the outer gas giants, also called the Jovian planets, on our model, but we're still missing the 4 inner planets and the asteroid belt. Fold your paper again, this time folding the end marked as the Sun to where Jupiter is. Here, your new crease lies halfway between 0 and 5 at 2.5 AUs. The asteroid belt begins a little before 2.5 AUs and extends until about 4 AUs. The asteroids don't live within a single orbit, but in a range of orbits, which is why it's called a belt. All my little X's here represent the area where the majority of the asteroids in our solar system lie. Make one more fold, this time folding the sun to where the asteroid belt crease is. That crease marks 1 1/4 AUs. Mars is a little farther away than that at 1 1/2 AU, so I'm writing it to the far side of the crease. The Earth is a little closer to the Sun than that at exactly 1 AU. Remember that the AU is defined as the average distance from the Sun to the Earth. I've marked the Earth on the opposite side of the crease. We're getting to the point that folding the paper isn't really necessary anymore, as we've only got 2 more planets and not much space remaining. For the final 2 planets, just write in Mercury at 0.4 and Venus at 0.7 AU. Notice that these numbers are decimals, less than 1, because they're closer to the Sun than Earth is. Now you're done. You've created a model that accurately demonstrates how the planets are really spaced in our solar system. Notice how close together the inner planets are on this scale. But you don't go outside and see some massive ball in the sky for each of these planets. This means that the inner solar system planets are really far apart, but the outer planets are so very much more far apart. That's why they call space, space. There's a whole lot of space out there between objects. And as we get out of our solar system and talk about the space between stars, the space between objects is even greater. Finally, to submit your work, just take a couple of pictures of your beautiful model to show me you've completed it. Take one to show the full model like the one on the left. Even though the words are difficult to read, I can still tell that the spacing is correct. Take a second picture to show the first part so I can tell that everything is complete and to scale on the other end. Convert your photos to a PDF using one of the photo to PDF apps mentioned in the syllabus, or paste the pictures into a Word document. Just make sure the pictures are large and clear enough to read. Remember, I'm an old lady with old eyeballs. Upload your file to Canvas. In the next assignment, we'll be comparing the planets, their size scale, and several other characteristics about them.